in this first video, I want to look at some maps with you and talk about the distortions. I've got the word distortions written here. Maps always have distortions in them. Not even intentional distortions, but there are always distortions in maps that can create a particular kind of concept, like a mental construct of a place and of space that might not necessarily be reality. And so we have to, as geographers, try to interpret the maps that we are looking at and try to acknowledge the distortions that might be there so that they don't give us an inaccurate mental picture of what reality is, what space and place actually are in that particular situation. So one map that I want to start with, I hope I have it up here on the, nope, I don't, let's see. Okay, well, here is a picture of a variety of maps. I can show this one. Let me move me out of the way. But I know I have, there's a Mercator projection. Okay, so one of the problems that we have in making maps on this two-dimensional surface, there we go, is the fact that the Earth is a sphere, right? It's an oblate spheroid, to be exact. But the Earth is a sphere, and when you're trying to take this curvature portion, any curvature portion of the Earth, and make it flat to depict it, it causes distortions. So this is probably a map that you are very familiar with. It's a Mercator projection map. It's used primarily to show distance. It was created, distance and navigation. It was created centuries ago for navigation of the world. It put everything out flat so that you could see where you were in this, in the oceans as you navigated by boat around to the different locations in the world. However, these lines that I'm following with the arrow here, these lines are called longitudinal lines, and the lines across the horizontal lines are latitude lines. They are equidistant from each other. They mark equidistant numbers of degrees, minutes, and seconds of space. That's the way that we measure space on the globe. Latitudes mark a particular amount of degrees, minutes, and seconds above the equator toward the poles. They are equidistant from each other. However, as you look at the way this map, because we are trying to take that globe and spread it out flat, you see that the latitude lines are very close to each other down here and very far apart from each other down here. And so that's part of the distortion that this map puts in our mental concept of the world. If you only looked at this flat map to try to understand the world, a country like Greenland, which is where I'm pointing right here, which is actually very small. This country, Greenland, looks ginormous, if that's a word. It looks ginormous on this map. It looks almost as big or bigger than Africa, which is one of the largest continents on the planet. So this Africa landmass here is actually, I think it's 14 times larger than Greenland actually is. But if you looked at this Mercator projection, that's the distortion shows that this is huge and this is closer to the correct size that it would be on the globe, which let me go back here. So see this white area on the map there, that is Greenland, and here's Africa over here on the sphere. Here's Greenland up here on this partial conical projection, and here's Africa over here. See, so Africa is much bigger. Here's Greenland on the Mercator projection again, and Africa, it's actually much smaller than Africa is. But on the Mercator projection, that distorts the latitude and longitude because they're spreading it out into this rectangular form. You've got a different mental concept of what perhaps the world actually looks like. Some of the world projections like this one, for instance, that has fewer distortions in it, still fewer distortions of landmass size, it perhaps distorts the idea of north, south, east, and west, where we've got straight up, straight down, and straight side to side. The Mercator projection does north, south, east, and west really well, and that is one of the primary reasons why we use it for navigation. So when you open up your GPS on your iPhone or Google Maps or whatever you use, it is a navigational map that primarily works from a Mercator projection kind of way, because if a road runs side to side like this on a navigational map, you will see it depicted that way when you are looking at these navigational aids that we have in with our GPS, global positioning system software, that comes included in our smartphones and Google Maps and things like that. So it's important to be aware that there are many different types of maps, many different types of many different distortions that maps include in them, unfortunately. For instance, look at Antarctica down here on this particular map example. It looks enormous. However, on this particular map example, on the very opposite corner, Antarctica just barely gets a little bit of representation down here on the edge, because it's actually a very small landmass. This actually is a small-ish presentation of Antarctica that actually still, makes it quite larger than it actually is in reality, makes it appear quite larger than it actually is in reality. And look at the Mercator down here. Huge. Antarctica looks enormous, but it actually is not. So, okay, we're going to look at maps again in another video and talk about distortions some more and how they shape our concept of place and space and interaction. And so I'll see you in our next video.